Good morning to all. I'm going to start today the last unit, which is superconductivity. Today we're going to do it, which is very really interesting chapter to begin. Right, let me stop. And we're gonna watch some. I'm gonna show some interesting video also. Right. Right. So yes, yeah. So great. Welcome to this unit, last unit, which is really wonderful. Um, really great unit to discuss. I love this subject, even. I love this chapter too. So superconductivity. One question comes from the long answer and short answer. What is superconductivity? I mean, you can see here. Can you are you able to see the slide, please? What can you confirm it?
Yes, sir, we can see, sir.
Oh, great, thank you. So superconductivity. There are two words here. One is the conductivity. The other one is superconductivity. What are these? I mean, importance of this. What is this actually? When the conductor become a superconductor, when the conductors become a superconductors. I mean, this is really wonderful. As we all discuss, conductivity of the material is sigma. I mean, what is a superconductivity? What is the conductivity of superconductivity? The only difference between, I mean, we have already classified it, we have already discussed the semiconductor, insulators, and conductors. Here you have this really great value of sigma. Insulator is almost like a sigma is 0, and here is approximately like it's not so great, but it is a medium, I can say. Okay, here the contribution is whole send electrons. In this case, you have the both contribution electrons and holes. In this case, it's like a dielectric material, insulators, and here you have only electron contribution. So, but the question is here, superconductor. I mean, if you can able to design conductors like the wires which we connect between the pole to pole connection ఇస్తున్నాం కదా, if you can able to connect with superconductor, really we save a lot of energy. We don't lose any electricity. We're getting a current from the different ways: solar current, a normal hydrothermal current, coke. Lot of methods are there. But if you can able to produce, if you can able to design the wires with a superconductors material, then whatever we produce here, we can reach here same amount. Suppose how many, whatever the power we produce here, the same amount can be get it here without losing any amount of electrical energy. So that is a very challenging one. We are losing a lot of energy because of lot of thermal loss. When the current passing from the Nagarjuna Sagar to Hyderabad, the wires are laying in the atmosphere because of the temperature, because of the issues, because of the humidity. There's some amount of current loss. We lost it, right? And now, if you can able to make this wire with this, if you can able to make the wires with the superconductors, we don't lose energy here. Completely we don't lose energy. ఇక్కడ ఎంతైతే ఎనర్జీ ప్రొడ్యూస్ చేస్తున్నామో we can get it from here. So that is the importance of the superconductor. But can we already have, sir, this? Yes, student, there are some superconductors. The research is going really great manner. Lot of world scientists are working on this field, but still the challenge that I want to bring you, challenge ఏంటి సార్ అంటే, రూమ్ టెంపరేచర్ దగ్గర ఇవి పని చేస్తే దెన్ వీఆర్ రియలీ గ్రేట్ సైంటిస్ట్, అంటే నోబెల్ ప్రైజ్ వచ్చినట్టే. అంటే ఇప్పుడు kind of like we are approaching the 0 degrees. I mean, both basically they work at low temperatures, -20, -30, like that. They are really good. We already fabricated, made the superconductor at low temperature. But if you can able to make the conduct superconductor above, like 20 degrees at least, I mean, there is a research going on. They are able to coming above this right, this direction. So then we are really wonderful. The world becoming like a crazy world in next 10 years. So hope that you guys are going to be scientists and work on this field, and the pro give your contribution to the science community, give us a contribution to the world scientist forum. So hope that you can do this work. A lot of research is going on. I hope you can also join in our groups. Great, thank you. So, what I'm going to start. So, that brief introduction. I'm going to start actual classes. I mean, you can also see bullet train. What do you call it? This bullet train. Bullet train. What is this, sir? This works at the principle of the superconductor. Bullet train goes like 800 kilometer per hour. It may go 1002, like a flight on the ground. How, sir? Like to go from Hyderabad to Delhi, it just take 1 hour, 1 hour to 2 hours. That's it. So that is a technology. So that is our challenge. So do you want to contribute it? How do you feel it? Like once you contribute your work to this project, how do you feel it? You feel like anything. After next 1,000 years also, they remember you. Wow, Sushma Reddy contributed a research in this project. And they google it they google Sushma Reddy. Oh really? Oh, she did this project and she made this dimension. She discovered this. Like we are doing like Einstein contribution, we are doing the Raman research, everything that you do. Just type it. Even if you type my name, you can find some contribution to the science. Okay. So basically, so that is the happiness you get it from this field, science. Okay. So the question is, what materials are the suitable to make the superconducting material? Diamagnetic material. We already did it, right? What are the material that we use it, please, Sushma? Diamagnetic
Diamagnetic material.
material, right? Okay. So moving into the what I'm going to discuss in this unit, superconductor. What are the superconductors? Discovery. Who discovered it? What are the basic properties that we are going to discuss it, and the importance basically, the importance. Someone can admit, Shailaja, and importance factors, and what are the types of superconductors? And what are the high TC superconductor means high temperature. And temperature increase చేస్తే సూపర్ కండక్టివిటీ ఏమవుతుంది? అండ్ మ్యాగ్నెటిక్ లెవిటేషన్ అంటే బుల్లెట్ ట్రైన్స్, అంటే గాలిలో వెళ్ళే ట్రైన్స్ భూమి మీద టచ్ అవ్వవు, పైకి వెళ్ళవు, జస్ట్ దే ఆర్ వెరీ క్లోజ్ టు ఫీల్డ్ లైక్ గ్రౌండ్. Those are called bullet trains. They work on the principle of magnetic levitation. And Josephson concept and some kind of application. So this kind of like you can get like 16 to 20 marks from this chapter. Okay, so very easy. I mean, very easy to score. I'm trying to say that. So compared to other chapters, very easy. And tell your friends to attend all the next classes. Right. So coming to the okay, what are the superconductors? Now the great topic that what are the superconductors? I mean, believe guys, we learned this in my master level. See, 2000 we started my master MSc. That time I got to know this superconductivity. When I was in degree, I didn't even know that. That time The syllabus was actually old version. We didn't learn this superconductivity in bachelor level. Really wonderful opportunity learn to teach you guys or to for you also. Really it helps a lot to understand. You can teach this to your friends. Really great. Okay, superconductors, don't really, you can word using the super itself, like very glad that superconductors are the materials having the almost zero resistivity. Remember this very important word, and resistivity and resistance both. The superconductor, what are the superconductor? First point, what you need to know, sir, resistivity zero ఉన్న మెటీరియల్ అన్నిటిని సూపర్ కండక్టర్స్ అంటారు సార్. Really great. Yes, the superconductor are the material which are having the zero resistance, zero resistivity, and behaves as a diamagnetic material below transition temperature. So they are called superconductors. One word answer చెప్తాను చూడండి. సూపర్ కండక్టర్ అంటే ఏంటిది? If I ask maybe Narasimha, so you should tell like, sir, very easy sir, the material which having the resistivity zero, the material which are having the resistance zero, the material which are having the resistance zero at below transition temperature is called superconductor. Right? And the superconductivity is the flow of electric current. Superconductivity is the flow of electric current without resistance. Remember this. Without resistance. And certain metals, alloys కావచ్చు, అవి metals అవ్వచ్చు, alloys అవ్వచ్చు, ceramic material అవ్వచ్చు, and
Bye, sir.
so temperature near absolute zero or low temperatures too. Any doubt, please? Chepnana. Hello? Any questions? సో సూపర్ కనెక్టివిటీ అంటే మీకు తెలియాలి. నార్మల్ కండక్టివిటీ, సూపర్ కండక్టివిటీ. నార్మల్ కండక్టివిటీకి రెసిస్టెన్స్ జీరో అవ్వదు. వేరే సూపర్ కండక్టివిటీకి ఇవి రెండు ట్రూ, దే వర్క్ అండ్ వెరీ లో టెంపరేచర్స్. సో నౌ ద డెఫినేషన్ షుడ్ బి క్లియర్ ఫర్ ఎవ్రీబడి. I know, sir, the superconductor are the material which have the resistance zero at below transition temperature. Is it clear? And what are the materials suitable for this, sir? Diamagnetic materials or alloys or ceramic. They work at near about zero temperature, or some materials should be at low temperature too. Zero means 273. Zero means itself minus 273 Kelvin, converting 0 degrees to. I mean, this is the important, the definition itself very important concept to know that. Any doubt in the definition, please? Students, can
No, sir.
ఏం డౌట్ లేదు కదా?
ఏం లేదు.
సూపర్ కండక్టర్స్ అంటే ఏం లేదు, రెసిస్టివిటీ జీరో అయ్యే మెటీరియల్స్ అన్నీ కూడా సూపర్ కండక్టర్స్. మోస్ట్లీ డయామాగ్నెటిక్ మెటీరియల్స్, సమ్ టైమ్స్ సెరామిక్ మెటీరియల్ ఆర్ అలాయ్స్ కంటే కొన్ని మిక్స్డ్ మెటీరియల్స్ ఆర్ మెటల్స్ కెన్ ప్రొడ్యూస్ ద సూపర్ కండక్టివిటీ. సో దే ఆర్ లైక్ ఏ మోర్ కండక్టివిటీ దెన్ ద కండక్టర్స్. Conductors having the zero, they don't have the zero resistivity, whereas superconductors have the zero resistivity. If differences conductors and superconductors. Someone asks you, can you differentiate conductors? You should immediately tell, no, I know this. Superconductors having the resistivity zero, sir, whereas conductors, they don't have the zero resistance. That's a bullet point that you have to keep in your brain forever, not today, not tomorrow, till the last day of your life. Okay? Can you remember it?
Okay, sir.
Yes, thank you. The next slide, I'm going to, okay, what's going on? Let's wait. Yes. So you can see now, yeah. So discovery, as I mentioned in the last slide, what is the who discovered the great guy, really great scientist? We have to close your hands and pray to him. Really wonderful person. Superconductivity was the first discovered by the great scientist, Dutch scientist Kamerlin Wons in 2000, sorry, 1911. See, how many years back he did see? Very soon. Not even like, I mean, how many? 100 years? Do you think it? More than 100 years. Like, our grandparents. As a my grandpa, I would say definitely. Grandparents for you, maybe. I don't. Yeah, 1911, just 110 years back. That's it. Not like a 2000 years back. No. So superconductivity was first discovered by the great scientist. He's a physicist, he's a physics guy, and Cameron Horns. And now everybody using superconductivity in chemistry, material science engineering, mechanical engineering, everywhere, industrial engineering, design engineering, all fields we have been using it because of our greatness of physics. See, okay, who discovered Camerlin Horns? The way you speak is no, pronounce is Kamerling, don't say Kamerlin owns 1911. Okay, that's good, sir. Oh, wonderful information that we got to know now. The how actually the discovery happened. Once actually felt that a cold wire resistance, he was doing the cold wire resistance would dissipate, and this suggested that there would be a steady decrease in the electrical resistance. He was trying to do some experiment at low temperature, beta. At low temperature, he was trying to do measure the ఒక వైర్ యొక్క రెసిస్టెన్స్ మెజర్ చేస్తూ ఉన్నాడు. సో సింప్లీ గోట్ టు నో దట్ at low temperature its resistance becomes almost decreasing. అంటే టెంపరేచర్ తక్కువ అవుతున్న కొద్దీ రెసిస్టెన్స్ డిక్రీజ్ అవ్వడం అబ్జర్వ్ చేశాడు, allowing better conduction of electricity. So at some very low temperature he observed that scientists felt that there would be leaving of the as resistance reached some all hill defined minimum value, allowing the current to flow with little or no resistance at all. After the further the other research scientists discovered that completely resistance is zero, and once passed a current through a very pure mercury wire, and it took a Hg wire, measure its resistance as he steadily lowered the temperature, and much to his surprise, there was no resistance at this temperature. Very important bit for the competitive exams. At what temperature for a mercury wire it behaves like a superconductor? 4.2 kilo Kelvin temperature. They'll ask, at what temperature mercury conductor behaves like a superconductor? Sir, I know that. What is that? It should be 4.2. 4.2 Kelvin, and Hg behaves like a SC superconductor. Is it clear? Students, is it clear? Say yes, no, yes.
Yes, sir.
Okay, just open your mouth and say, I don't want too much. Okay, can you see his experiment how he did it? Mercury, see, this is the temperature beta, Kelvin, and this is the resistance. Think about resistance only. Resistivity, resistance. We know that what is the rho L by A. Both are same dimensionally. Resistivity 0 means resistance also 0. Both are proportional. And these are the dimensional quantities L and A. So at a particular temperature suddenly dropped it to 0. This is the important graph also to remember. Can you find the following graph? Which one indicates the material behaves like a superconductor? Yes, sir, I know it. This is what? Because I can see that at 4.2 K, the y-axis quantity, which is their resistance, R suddenly fell into 0. Here resistivity is 0. So this is the important graph that you all have to remember it. Completely vanished, and it behaves like a superconductor. Conductivity is max completely. The flow of electron is great manner. They behaves like a superconductor. Which material with behave this graph indicates? Mercury beta. Oh, sorry. Right. So what are the general properties? You should remember this also. What are the general properties? Also important to remember. They'll ask 4 marks question. What are the general properties of the superconductors? So general properties, these are the what you call it? General properties. General properties. 4 marks question. Properties of SC superconductor. 4 marks question. What are the general properties of superconductor? We already discussed it. This guy virtually zero electrical resistance. Electrical resistance should be zero. So first point is its electrical resistivity or resistance zero. The second point, take the important note down that effect of impurities. When impurities are added to the superconductor, the superconductivity is not lost, but HTC lower. It's a very important point. Alloys, I said, right? Alloys also can behave like a SEs, superconductors. At why? Alloys means we don't want to, temperature should be 4K. If the temperature is 4K, low temperature, I can't, we don't have much applications. We want it to be at room temperature. We want to, the material should work at a room temperature like at least 10 degrees Celsius. How do we get back to here? By adding some impurities. అంటే కొన్ని మెటల్స్ని కానీ కొన్ని ఇంప్యూరిటీస్ని యాడ్ చేసి టెంపరేచర్ని మనము రూమ్ టెంపరేచర్కి తీసుకురాగలిగితే మీన్ it's not room temperature but at least close to the 20-25 or 10 to 25, then we can use these superconductors to make so many devices, so many electronic devices, so many conductor, like in the communication process, like wire makings with using superconductors, lot of applications better. So when you add impurity, they do not change the superconductivity. What they change? They change the temperature to bring it to room temperature. The first point you know it, resistance 0 అవుతుంది. Second point, impurities add చేస్తే superconductivity తగ్గదు, but its temperature should lower. What temperature? TC. What is TC? Transition temperature. ట్రాన్సిషన్ టెంపరేచర్ అంటే అది సూపర్ కండక్టర్ నుంచి ఇలా డ్రాప్ అయింది కాబట్ట కంప్లీట్గా ఇది 4K దగ్గర. ఓకే, ఇది టెంపరేచర్ కదా, ఇది మనము తగ్గిస్తున్నాం 4K నుంచి. వీ వాంట్ టు బ్రింగ్ ఇట్ 0 degrees Celsius ఫస్ట్. సో దిస్ షిఫ్ట్ షుడ్ గో హియర్. So by adding some kind of impurities to the superconductor, we are trying to decrease the transition temperature. The other important effect of pressure and stress. Stress is nothing but force. Pressure also forced by area only, right? Both are same. Certain materials exhibit superconductivity and increasing pressure in a superconductor or increasing stress result what it result increasing TC value. So the main research is now to bring the transition temperature, bring the temperature of the superconductor to a room temperature. అంటే సూపర్ కండక్టర్స్ రూమ్ టెంపరేచర్ దగ్గర పనిచేసి వర్కింగ్ అయ్యేటట్టుగా we need to bring that research. That is the focus of research. So you can do some pressure applications, you can apply some stress application, apply the force, but in order to change this TC value, you can add the impurities, you can also change the pressure or stress in order to change the transition temperature. So now is it clear for all of you? General properties, is it clear?
Yes, sir.
Three properties you can keep in the brain. The first property should be electrical
Yes, sir.
zero, sir. Impurities and pressure stress also can alter the transition temperature, and but without changing the superconductivity behavior. The main focus of the research is to bring the temperature to a room temperature. The material which work, the superconductor which function at room temperature, so that there are a lot of applications, right? The properties over, and this is a very important. What is this? This is also long answer they asked last year, I guess. uh, Long answer means they split the definitions. So what is isotope effect? This is also one of the property, general property. This is also one of the general properties. Also they're going to ask long answer. So we already discussed three: impurities adding, of pressure, stress, and resistivity zero, and other properties isotope effect and magnetic field effect. These are the five. You can get 6.67, 10 marks sometimes. The critical transition temperature beta value of superconductor is found to vary to its isotope mass. Sir, I mean, most of you know isotopes. What is isotope beta? Isotope means the material which are having the same chemistry lo నేర్చుకుంటారు, same atomic number but different mass number. వీటిని ఐసోటోప్స్ అంటారు. మెటీరియల్ విచ్ ఆర్ హ్యావింగ్ ద సేమ్ అటామిక్ నెంబర్ బట్ డిఫరెంట్ మాస్ నెంబర్ ఉన్నటువంటి అన్ని కూడా మనకు గివ్ మీ 1 సెకండ్ సార్. ఐల్ గివ్ కాల్ యూ సార్. క్లాస్ అయిపోతుంది, 5 minutes క్లాస్ అయిపోతుంది. సార్ ఓకే సార్, ఓకే సార్, రైట్ సార్, థ్యాంక్ యూ. రైట్. So you can see the other property, the transition temperature. You can see it directly proportional to the 1 by root m nana. 1 by root m. It is transition temperature is inversely proportional to square root of the isotope mass single superconductors. So Tc is inversely proportional to root m, where m is the isotope. Very good property. General properties of first one we completed, resistance zero. Second, it also impurities. Third one, stress. Fourth one is isotope effect, which is this formula. And the fifth point is what? If a strong material, strong magnetic field applied to the superconductor below transition temperature, the superconductors undergo transition from superconductor to the normal conducting state. అంటే మ్యాగ్నెటిక్ ఫీల్డ్ అప్లై చేస్తే సూపర్ కండక్టర్ని మనము నార్మల్ కండక్టర్ కూడా కన్వర్ట్ చేయొచ్చు. This is the fifth point. When you apply this magnetic field, you can bring the superconductor to the normal conductor. So this is the, I mean, I hope you understand. I hope you followed the class. Any doubt, please let me know. General properties. Does anybody have the questions about the normal general properties of superconductors? Do I need to repeat it, or can anyone give the response? If you have a doubt, please unmute and talk to me. చెప్పండి చెప్పండి. మీకు ఏమైనా డౌట్స్ ఉన్నాయా ఈ జనరల్ ప్రాపర్టీస్ సంబంధించి? No doubts?
Yes, sir, no doubt.
Oh, great. Can you, Sushma, can you let me close this and I'll ask the question. If you say no doubt, tell me 5 points which I discussed. One of you. Can I ask someone, not Sushma? I don't know. Maybe I can ask Shailaja or Swapna. Swapna, are you there? Swapna? Swapna? She's not there. Shailaja? I'm going to ask boys. Shankar? You should tell them. Vamshi? Are you there, Vamshi?
Sir.
Are you Shailaja?
Sir.
ఒక 2 పాయింట్స్ చెప్పినాను which ఒక 2 ఇంపార్టెంట్ జనరల్ ప్రాపర్టీస్. టెల్ them. ఒక 2 ఇంపార్టెంట్ జనరల్ ప్రాపర్టీస్ చెప్పేట. Swapna, are you there? Nana, మీరు వింటున్నారా క్లాస్? Are you guys are attending classes or just opening, I mean just keeping the mobile there and leaving the class? I mean doing your work. Sushma, can you tell that? Sushma?
Sir,
Yeah, tell at least 2 or 3 points general properties.
in electrical resistance,
Okay.
zero electrical resistance, sir.
Okay, the electrical resistivity or resistance of the superconductors 0, right? Okay.
Yes, sir.
Then
In transition energy is low.
no, something like we have to talk about the second point. What I was talking.
Effective of impurities.
Yeah, impurities add chest emotundi. What happened? It doesn't. Impurities do not change the superconductivity, but what they do, what they change? They change transition temperature, right?
Yes, sir.
So impurities, they do not change the superconductivity behavior, but they just affect on the transition temperature. Then third point.
Transition and temperature.
Third point.
Effective of pressure and temps.
Yeah, effectiveness of the pressure and stress. What
Stress.
they do, they also affect on the transition temperature without changing the superconductivity behavior. Fourth point.
Isotope effects, sir.
Isotope effect. What they do? What it do? Transition temperature of the transition temperature of the superconductor inversely proportional to the
superconductors.
no
Square root of isotopes.
Mass. Square root of the isotope mass, right?
Isotope masses.
Yeah, it's definitely what is it's inversely proportional to the isotope mass. Then the last
magnetic field effects.
what it does,
it breaks down the superconductivity to the conductivity.
So it just break down the superconductivity, like it can, by applying more magnetic field you can convert it to the normal conductors. I mean
conductivity.
Very good. Thank you. The next, yeah, I think everybody should remember that. Did you fill the attendance?
You didn't send, sir.
Really? I think I thought I did it, right?
No, sir.
Let me go for it. You Zoom, that is Zoom. I don't want that. Hmm. I didn't even show this superconductivity. One thing I want to show you today to make it you comfortable. Yeah, I just send the link better. Not Sapna, everybody. So I want to share now. I think the general properties are completed. Tomorrow I'll discuss others, Misner effect and other. Now I'm going to show you one of the video that I would like to share. Can you, are you able to see the superconductivity is a video? Exactly zero electrical resistance and expulsion of magnetic fields. Students? Certain materials, when cooled below, are
Yes,
characteristic
sir.
temperature. Generally, the electrical resistivity of an ordinary metallic conductor decreases gradually as temperature is lowered. Even near absolute zero, a real sample of a normal conductor shows some resistance. But in a superconductor, the resistance see normal and superconductor differences when the material is cooled below. So here you can see that an electric current flowing through a loop of superconducting wire can persist indefinitely with no power source. This property of a superconductor has enabled us to use superconductors in many applicants and machines, and a superconductor has many uses in the modern world. Some of the major applications of superconductors are electromagnets. Superconductors are some of the most powerful electromagnets. Yeah, you can separate the metals from the dust. Used for magnetic separation. When a superconductor electromagnets is placed over a mixture of weakly magnetic particles and less or non-magnetic particles, the weak magnetic particles gets attracted to the superconducting magnet. Magnetic levitation. A superconductor repels the magnetic lines when cooled below the critical temperature. That is, it repels a magnet when approached towards it. This property is used in operating maglev trains. Maglev is short for magnetic levitation. The tracks are supported with propulsion coil and levitation and guidance coil. The train in its base has superconductor magnets. Since the superconductor repels a magnet, the maglev train floats in the air. Correct. Using the propulsion coil and the magnets placed in the base of the train moves over the tracks. Right this moment, there is a mad rush in America. Apple, Amazon, Facebook, dozens more. They're all betting on a radical. Right. Did you able to see the? I mean, did you watch it now? How do you? I mean, did you see the video? I
Yes,
mean,
sir.
the fly. I think I can close it. Stop.